Right. Greetings to you all, learners. Welcome to EduBlush Visual Academy. We are a group of professionals that are helping learners in math, science, accounting, and many more other subjects that are actually following. Thank you for following us. We are a group of professionals. We are full-time teachers teaching grade 10, 11, 12. And it's important to us that you guys, you follow us and you get whatever content that we are displaying here. It is important for us, for you to also inform other grade 11s that are doing the same subject, for them to know that there is EduBlush, which is offering free lessons for now. It's a privilege that you are being coached by people that are markers, senior markers, and that really understand the content that is as per your examiner's dictates. So today I'm continuing with my presentation on trigonometry. Right, this is our lesson 3 on trigonometry, and I'm busy with reduction formulae. The previous lesson was about reduction formulae, but looking specifically on functions that are deduced from the x-axis. Then today, we are now moving over to functions that are being deduced from the y-axis. So before you go through this one, I'll urge you to go back to lesson number 2 on trigonometry so that you can actually link up these lessons. Okay, right. So I'm going to look at your trigonometry. Allow me to prepare your board. Your trigonometry. This is a very, very simple section. I'm sure you are going to like it. Let's develop this together. Let's develop it together. Trigonometry. There you go. Trigonometry. Right. Right. Trigonometry. Right. I'm specifically looking at reduction formula. Reduction formulae. There you go. There you go. That's the section that I'm going to be looking at. Reduction formulae. Specifically focusing on functions deduced from the y-axis, functions that are coming from the y-axis. Okay, there you go. Right, reduction formulae. Okay, I defined what reduction means, and I say this is a word deduced from reducing. In math, it means you're simplifying. Just like what you're doing in grade 7, reduce this fraction to its simplest form. Then it's as good as just saying simplify this to its simplest form. So in this case, we are simplifying trigonometric expressions to their simplest form. That's what you're coming up with. So I'm coming up with, or I'm deducing a path that you should use to reduce or to simplify trigonometric expressions given in different forms. But specifically today, I'm looking at those that are functions that are coming from the y-axis. Right. Now, functions that are coming from the y-axis. If you go back to your cast diagram, there you go. This is my cast diagram, or the Cartesian plane if you want. Right. Now, on my cast diagram, remember, angles, they stretch from negative infinity to positive infinity. Any angle measured in an anti-clockwise direction, it means that angle is a positive angle. Any angle measured in a clockwise direction, then that means that angle is actually a negative angle. So if I would measure 0, 90, I'm going in an anti-clockwise direction, so these angles automatically they're going to be positive. Right. So don't be surprised when you meet negative 90 degrees or negative 180 degrees. It means those angles will be measured now in an anti-clockwise direction, in a clockwise direction rather. Right. Now look at that. I've got my angles. Today I'm looking at functions that are coming from the y-axis. In the previous lesson, we were looking at functions that were coming from the x-axis, and we spoke of 180 plus or minus theta, 360 plus or minus theta. You can go for the second rotation, 540 plus or minus theta, 720 plus or minus theta, that kind of a thing. Okay, right. Now, I'm now looking at functions that are coming from the y-axis. How do I form functions that are coming from the y-axis? I'll look at the first one. Look at 90 degrees. Remember I said theta is an acute angle. If theta is an acute angle and I subtract it from 90 degrees, any acute angle subtracting from 90 degrees, take 30 degrees, it's an acute angle. An acute angle is an angle which is between 0 and 90. So if I subtract 30 from 90, I'll get 60, and 60 is an acute angle. Okay, meaning to say 60 is in the first quadrant. So if I subtract a theta from 90, I'll get an angle which is in the first quadrant. Take 90, subtract 20, you get 70 degrees. That is in the first quadrant. Take 30, take it from 90, you get 60 degrees, first quadrant. Take 40, subtract it from 90, you get 50, which is in the first quadrant. So as long as you're subtracting an acute angle, any acute angle, call it theta, from 90 degrees, you get an angle which is in the first quadrant. So hence the function 90 minus a theta is in the first quadrant. What about if I'm adding theta to 90 degrees? Which quadrant do I go to? Take your theta to be 10 degrees. That will be 90 plus 10, which is 100. Now you're in the second quadrant. So it means 90 plus a theta is now in the second quadrant. As long as you're adding an acute angle, as long as whatever you're adding is between 0 and 90, you always land in the second quadrant. Take something like, okay, you're adding 30 degrees to 90, you get 120, and 120 lies between 90 and 180, which is in the second quadrant. Okay, so that's your first quadrant, that's your second quadrant, this is your third quadrant, and this is my fourth quadrant, something like that. Okay, now I'm done with that. I'm now coming to the third quadrant. In the third quadrant, I'm now looking at 270. If I subtract something from 270, I'll get into the third quadrant, which is 270 minus a theta. Take theta to be 10 degrees. Subtract it from 270, you get 260. 260 is between 180 and 270. Hence, that angle is now in the third quadrant. Subtract any theta from 270, you will see that you get into the third quadrant. Okay, what about when I'm adding a theta to 270? Theta, take your theta to be 10 degrees. Remember, it's an acute angle, we get 280. 280 is where? It's actually in the fourth quadrant. So function 720 plus a theta is in the fourth quadrant. Good, right. These are functions that are coming from the y-axis. You can see that they are made up of 90, they are made up of 270, 270 and 90 on your cast diagram, they're coming from the y-axis. Okay, if I go for the second rotation, it means that becomes 450. All I'm saying is 90 plus 360 plus a 90, 450. 450 plus 90, that's 540. 540 plus that, plus 90, it's also 630. 630 plus 90, 720. What am I saying? 450 and 630, they are also from the y-axis. If I subtract a theta from 450, I'll also go to the first quadrant. Then 450 plus a theta, that's in the second quadrant. Then what is that one now? 630 minus plus a theta, 270 minus a theta, on and on like that. You should always remember to change from the given trigonometric ratio to its complementary function. If the given is sine, you change to cos. If the given is cos, you change it to sine. Very, very important. Allow me to write that in terms of conclusion. Then we'll be able to look at specific examples and how you're going to be using this. Okay, an important conclusion, NB. Okay, very, very important. When a function is deduced, when a function is deduced from the y-axis, in this case, one should, in other words, you should or you must change the trig ratio to its core or complementary function, which is the core function. Okay, meaning to say when you've got sine, you change it to cos. When you've got cos, you change it to sine. Okay, I will show you that with an illustration and an example. Right, let's look at the other conclusion. Right, just a quick one there. If I've got something like sine 90 plus a theta, reducing this, since 90 is coming from the y-axis, supposed to change to complementary function. But the first thing is look at the quadrant where 90 plus theta is. 90 plus theta is in the second quadrant. What is sine in the second quadrant? It's a positive. Then change it, since it's coming from the y-axis, to its complementary function, which is cos. So that will be cos theta, positive cos theta, something like that. Okay. The next important conclusion there is when a function is deduced, when a function is deduced from the x-axis, one should or you must keep or maintain the same, underline the word keep, or maintain the same trig function when simplifying. Simplifying. Okay, when you're simplifying, one should always keep the same trigonometric ratio. Just like in the previous class when we said sine 180 plus a theta. 180 plus a theta, we said 180 plus is in the third quadrant. What is sine in the third quadrant? Sine is negative. So that reduces to a negative sine theta. The emphasis is I started with sine 180 plus a theta, and my answer is going to be negative sine theta, meaning to say the trigonometric ratio did not change. We started with sine, we ended up with sine. Okay, that is sine 180 plus a theta, and that answer is just negative sine theta. That's what we did in the previous class. Okay, right. Now let's look at the strategy that I'm using there. Let's look at quick pointers that you need to always remember when you are reducing functions. When reducing your functions, when dealing with reduction, formulae. Right. Focus on the following. Focus on the following questions. These are the questions that you are supposed to ask yourself as you are reducing. The first question is in which quadrant, right? In which quadrant does the angle lie or the function lie? Okay, right. That will help us determine the sign, which is very, very important. So the quadrant helps us identify the sign of the reduced expression. Right. The next one, what is the sign of this ratio or trig ratio? What is the sign of this trig ratio in this quadrant? Okay, the third one, does the ratio change? Does the ratio change or remain the same? The same. Does the ratio change or remain the same? The function, is it deduced from the x-axis or the function is deduced from the y-axis? If it's coming from the x-axis, it remains the same. If it's coming from the y-axis, then you change to its complementary function. Okay, so that's how you will know whether you are changing the trigonometric ratio or you are maintaining. If if that expression is deduced from the y-axis, change. If that expression is from the x-axis, they keep it the same. Okay, let's look at a quick example on this and see how I'm going to be doing that. Okay, right, let's look at an example here. Right, example 1. Right, look at the example. Write the following. Write the following as ratios of theta. Okay, or someone can say write it write it in terms of its acute equivalence. It's basically the same question. Okay, right. So I'm going to say, there you go, sine 90 plus a theta. Okay, that is the first expression that I'm going to simplify, sine 90 plus a theta. Look at this. I'm trying to simplify this expression. I'm trying to reduce this trigonometric function. The first thing is to check the quadrant where this belongs. I can see that if you quickly go back to your cast diagram, this is a function 90 plus a theta. We said 90 minus a theta first quadrant, 90 plus a theta in the second quadrant. I'm deducing it from the y-axis. So look at this. This is going to be 270 minus a theta, quickly 270 plus a theta, something like that. 90 plus a theta is basically in the second quadrant. The question is, what is sign in the second quadrant? Is it positive or is it negative? In this case, sign is positive. in the second quadrant. So this reduces to what? First, I was just determining the sign by just locating the function. The next thing is I'm supposed to check, was this function coming from the y-axis or is it coming from the x-axis? 90 degrees is coming from the y-axis, so this changes to cos theta. Whenever a function is coming from the y-axis, you change to its complementary function from sine to cos. Okay, let's look at the next one. I've got tan 360 minus a theta. Look at this. Start with the angle. I'm going to start with my angle 360 minus a theta. Which quadrant is this one? 360 minus a theta is the fourth quadrant. If you go to your reduction formulae in the previous class, we said this is in the fourth quadrant, because if I go to my cast diagram, 360 is there, and I subtracted theta, I'll come back to the fourth quadrant. Now, what is sine? What is 10 in the fourth quadrant? It is negative. Okay. Something like that. Okay, look at my third example there. I've got cos what? 180 plus a theta. Look at the function. Where is this function? This function is in the third quadrant. What is cos in the third quadrant? Is it positive? Is it negative? Cos is negative there. Now, if it's negative, my question is, where is this function coming from? Is it from the x-axis or is from the y-axis? This is the x-axis, so it remains cos theta. Good, right. Okay, let's go to C. Now, C, I've got cos 450 plus a theta. This is cos squared 450. Right, look at this, there's a square, so I'm going to say cos 450 plus a theta, open a bracket and say all squared. There you go. Now, where is this function? That's the most important thing. Someone can quickly see from your reduction formula, this is in the second quadrant. In the second quadrant, what is cos there? Cos is negative in the second quadrant. Okay, right, still open your bracket because there's a square. Cos is negative. But where is the function coming from? 450. It's on the y-axis, so it means you're going to change to sine theta. Now close that and square it. My answer is going to be what? You're squaring a negative, then this will be sine squared theta. Okay, right. My last example there, which is D, is sine squared what? 180 plus a theta. It's a square. Look at this. I'm going to write it as sine 180 plus a theta, close that, all squared. There you go. Now simplify what is inside the bracket. Start with the angle. Which quadrant is this? This is the third quadrant. So I'll come and say, what is sine in the third quadrant? Is it positive? Is it negative? That is negative. Now, open that, you are supposed to close and square it. But where is the function coming from? Is it from the x-axis or from the y-axis? 180 is from the x-axis, so this remains negative sine theta. Now square that, that will give us what? Positive sine squared theta. Okay, right. Now that's what you are supposed to do when you are reducing functions, specifically those that are from the y-axis. I was just trying to mix it up so that you can manage the two, both those that are coming from the y-axis and those that are coming from the x-axis. Right. Now, whenever you get a function that is coming from the y-axis, then it means you are supposed to change from one function to its complementary function. If it's sine, it goes to cos. If it's cos, it goes to sine. Then any function that is deduced from the x-axis, the trigonometric ratio remains the same. If it's a sine, it ends up with a sine. If it's a cos, it ends up with a cos whenever you are reducing that. Okay, right. Just for interest sake, I'm just going to give you one or two for now that you're going to use, that you're going to look at, and I'm going to then post on your platform, EduBlush, more questions on this. You keep on interrogating these things. You keep on checking step by step. Where is this function coming from? Is it the x-axis? Is it the y-axis? Am I going to change? Am I going to keep the ratio? That's where the concept is. This is what you are supposed to. That you are supposed to be able to do. Right. Just a quick one. Cos 360 minus a theta minus sine 450, say, plus a theta. There you go. Right. Close that. Okay. Now, I just want us to attempt that. Is you'll be waiting for more and more activities on this. Thank you for your time. I hope and pray that you manage to follow what this lesson was all about. Glad we've managed to, right, I'm glad that we've managed to go through all everything about this lesson. I hope and pray that you've mastered reduction formulae. I'm going to proceed to the next class, which is lesson number 4 on trigonometry, when I'll be basically looking at reducing numerical angles. I wish and pray that you guys, you go through each and every video, go through each and every lesson, and try to consolidate the information that you're getting. As we are building on these things, make sure that you master the first lesson before you proceed to the next one. Otherwise, you end up mixing up things. This is your trigonometry. Trigonometry is very, very simple. Thank you for following us on EduBlush. Keep in touch. Invite more of your friends. It's a free platform for now, and make sure that you spread the word and help your friends that are struggling with this section. Thank you. God bless you. Keep following.